Is there life beyond Earth? It's a question that has haunted humanity for centuries. Every time we look up at the stars, we're not just seeing points of light, we're seeing possibilities. Billions of stars, billions of planets, and maybe, just maybe, we're not alone. Let's start with some perspective. Earth is one planet, orbiting one average star in one galaxy among hundreds of billions. And our galaxy, the Milky Way, may contain as many as 100 billion planets. Some scientists estimate that there could be over 40 billion Earth-like planets in our galaxy alone. Now multiply that by the number of galaxies in the universe, at least 2 trillion. The numbers are so staggering, they almost lose meaning. So if the universe is that big, and there are so many planets that could potentially host life, where is everybody? That's the heart of the Fermi Paradox. Proposed by physicist Enrico Fermi in the 1950s, it asks a simple question. If intelligent life is common, why haven't we seen any signs of it? Why hasn't any alien civilization visited us, contacted us, or at least left some kind of cosmic footprint? There are dozens of possible answers, and they range from hopeful to terrifying. One possibility is that intelligent life is incredibly rare. Sure, microbes might be common. Maybe even basic life forms like algae or bacteria exist on thousands of planets. But life that evolves into intelligent, spacefaring civilizations? That might be 1 in a billion, or even less. After all, Earth has been around for 4.5 billion years, and humans have only been here for a tiny fraction of that time. Civilizations rise and fall, and cosmic windows of opportunity might be short-lived. Another possibility is that life is common, but intelligent life tends to destroy itself. Think about it. We've had nuclear weapons for less than a century, and we've already come close to wiping ourselves out more than once. Add in climate change, artificial intelligence, biological weapons. It's not hard to imagine that advanced civilizations often self-destruct before they can reach the stars. Then there's the idea of the Great Filter. This theory suggests that somewhere between the formation of planets and the development of spacefaring civilizations, there's a barrier, a step that's nearly impossible to pass. Maybe it's the origin of life itself. Maybe it's the leap from simple cells to complex multicellular organisms. Or maybe the Great Filter is still ahead of us. But let's not get too dark just yet. Let's talk about where we are looking for life and what we've found so far. First stop, Mars. Once upon a time, Mars had rivers, lakes, maybe even oceans. It had a thicker atmosphere and a magnetic field. In other words, it was potentially habitable. Today, Mars is a frozen desert, but we found signs that liquid water may still exist underground. More importantly, we found organic molecules, the building blocks of life, in Martian soil. Did life ever exist there? Could it still exist, hidden beneath the surface? Next, Europa and Enceladus, moons of Jupiter and Saturn, respectively. They're covered in ice, but beneath that ice, oceans. Global oceans of liquid water, kept warm by tidal forces and geothermal heat. On Earth, we found entire ecosystems living around hydrothermal vents deep in the ocean, completely cut off from sunlight. Could the same thing be happening on these distant moons? Then there's Titan, Saturn's largest moon. Titan has lakes, rivers, and rain. Not of water, but of methane and ethane. It's like an alien Earth, frozen and weird. Some scientists think exotic forms of life could exist there. Life based not on water, but on methane chemistry. And beyond our solar system? That's where things get really exciting. In the last 30 years, astronomers have discovered over 5,000 exoplanets, planets orbiting other stars. Some of them are in the habitable zone, the right distance from their star for liquid water to exist. Some are rocky, Earth-sized, and orbit stars not so different from our Sun. One of the most intriguing systems is TRAPPIST-1, which has 7 Earth-sized planets, 3 of which are potentially habitable. So we know the ingredients for life are out there. Water? Check. Organic molecules? Check. Energy sources? Check. The question is, are the conditions right for life to actually begin? On Earth, life began very quickly. As soon as the planet cooled enough to support liquid water, life appeared. Simple life, like microbes, formed within a few 100 million years. That suggests that life, at least in simple forms, might be a natural consequence of chemistry. Give the universe the right ingredients and enough time, and life might just be inevitable. But intelligent life? That's another story. It took nearly 4 billion years for intelligent life to evolve on Earth. Along the way, there were countless extinction events, asteroid impacts, supervolcanoes, global ice ages. If just one of those had gone differently, we might not be here. Evolution doesn't guarantee intelligence. Dinosaurs ruled the Earth for 160 million years and never built a spaceship. So even if life is common, intelligent life might be extremely rare. Maybe we're the first. Or maybe civilizations are spread so far apart in space and time that contact is almost impossible. That brings us to another possibility. They're out there, but they're not talking. Maybe advanced civilizations are deliberately staying silent. Maybe they're listening, just like we are. Or maybe they communicate in ways we can't even understand. Radio waves are just one way to send messages. What if they use quantum entanglement or gravity waves? Or some technology so advanced it looks like magic to us. There's also the terrifying thought that something or someone is out there and they're hostile. Maybe advanced civilizations know it's dangerous to broadcast their location. Maybe the universe is like a cosmic jungle, where the quietest species survive the longest. Science fiction has explored these ideas for decades, from peaceful alien visitors to terrifying galactic empires. But real science is catching up. Projects like SETI, the Search for Extraterrestrial Intelligence, have been scanning the skies for decades, looking for signals. So far, nothing definitive. Just a few tantalizing anomalies, like the famous WOW signal in 1977, but no confirmed messages. But we're just getting started. New telescopes like the James Webb Space Telescope are already changing the game. They can analyze the atmospheres of distant exoplanets, looking for biosignatures, gases like oxygen, methane, or carbon dioxide that might indicate life. We're entering an era where we might not just speculate about alien life, we might actually find it. And then there's the possibility that life didn't start on Earth at all. Some scientists believe in panspermia, the idea that life, or at least the building blocks of life, came to Earth from space, maybe via comets, meteorites, or even ancient alien probes. If that's true, life might not just exist elsewhere, it might be everywhere. So, is there life beyond Earth? We don't know yet, but we're looking. We're building better telescopes, we're sending robots to distant worlds, we're listening to the stars, and most importantly, we're asking the right questions. Because whether we're alone or not, the search itself changes us. It forces us to look outward and inward, to reflect on who we are, what life means, and what kind of civilization we want to become. Maybe we'll find microbes on Mars. Maybe we'll find strange creatures swimming in Europa's oceans. Maybe one day we'll receive a message from the stars, a hello from across the void. Or maybe the first aliens we meet will be the ones we become, as we take our first steps into the great unknown. One thing is certain, the universe is vast, mysterious, and full of possibilities. And the question of whether we're alone may be the most profound one we'll ever ask. Keep looking up, because the truth might be out there, waiting to be discovered.